Okay, hey everybody. Welcome to our final review here for the midterm. So I'm going to go right to the questions tonight. We're going to go over those. Hope everybody's having a good weekend. Tuesday does have their midterm on Tuesday. Thursday has their midterm on Thursday. Each TA posted the information to Blackboard and/or emailed you, so everybody should be set to go. So let's get started right away. And I'm going to go over 5 questions tonight. We did 5 in class last time, and there will be 5 questions this week. They won't be identical to these questions, but the themes will be very similar. So here we go. Our first question tonight. Find the Maclaurin series. Hopefully you had a chance to try these. Find the Maclaurin series for x squared ln of 1 minus 2x. And then we're going to use the ratio test to find the radius of convergence. So first of all, if you want to find the Maclaurin series for this, you probably want to use a known Maclaurin series that you can memorize, which was ln of probably the one we did in class was ln of 1 plus x. So that was one of the 3 Maclaurin series I told you to memorize. One was sine x, one was cosine x, the other one was ln of 1 plus x. So what we said in class, and there's a few versions of this, but the one that I think we used was negative 1 to the n, x to the n plus 1 over n plus 1. So that would be the natural log of 1 plus x. That would be our series here. Everybody agree on that? Give me a thumbs up. That's the one you memorized. So we have 3 Maclaurins. Okay, there's ln of 1 plus x. So now the idea is to build the Maclaurin for this entire expression. So we want to do this piecemeal. If we want ln of 1 minus 2x, wherever there's an x, we want to put in its place negative 2x right here. So that's the first thing we want to do. So all we did here was memorize natural log of 1 plus x. And then we made a substitution. The plus x became the minus 2x right here. So that was our first step. The next step is to bring the x squared into play here. So actually, there may be another intermediate step that could be helpful. So one of the things that we might want to do just to get us going here, we could bring the x squared back in and put it in front of the sigma. But we're going to have problems working with it because the minus 2x is protected inside the parentheses. So what I would probably do next, and it takes a couple of steps here to do it, what I'd probably do next is separate these two right here. So what I'd probably do myself is I'd have the series and I have negative 1 to the n. And then what I would do is I would do negative 2 to the n plus 1 and then x to the n plus 1. So I had negative 2 to the n plus 1 and then x to the n plus 1. And that, of course, is over n plus 1. So all I did here on purpose was get the negative 2 and the x out of the parentheses by raising each separately to the n plus 1. So that has advantages because in the next step, we're going to multiply by x squared here. So when you multiply by x squared, that goes in front of the sigma to start. We can clean this up, but I'm leaving it in raw form just for a minute here. Just give me a minute. And this has the advantage because in the next step, this x here can combine with this because of the distributive property. So the x squared can combine with x to the n plus 1. So moving right along here, we get negative 1 to the n. I'm going to clean this up in just a minute, but let me deal with the x. X squared, x to the n plus 1. Keep in mind, same base, add the exponents. So that would just be x to the n plus 3 over n plus 1. So technically here, you really would get full credit for the McLaurin series part of this. This would be okay, but you might want to change this a little bit more, and I'll show you in a minute. I think you're better off here raising both of these to the n plus one, and you'll see why in a moment. So while this is fine, getting ready for the ratio test and simplifying it, my recommendation would probably be to do the following: x squared ln of 1 minus 2x. And what I think I'll do here, is I'll leave the negative 1 to the n just for a moment. Hold on, I made a little bit of a gaffe here. Okay, so x squared ln of 1 minus 2x. What I think I'm going to do is raise that negative 2 to both of those things. So what I'm going to do here is negative 2 to the n and negative 2 to the first.
Professor?
Yeah.
So I think a lot of us, when we looked at this question, we were trying to use the definition of a geometric series to solve it by taking the derivative and doing all that. Is there a way to do that though, like after this?
No, I would not do that here. No. I mean, I guess, I wouldn't do that. Definitely not. I would not use geometric here.
Understood.
Yeah. I'm glad you brought that up. Negative 1 to the n. Yeah, just because the first question was geometric in the review didn't mean to tell you to do this geometrically. So I'm kind of glad you brought that up. So negative 1 to the n, this is negative 2 to the n, and then this is going to be negative 2 to the first. Again, this is me cleaning it up for the ratio test in just a moment. This is x to the n plus 3 over n plus 1. The last line was the right answer, but this is not required, this step, but it probably will be advantageous for the ratio test. So let's see. The reason I did this here is because there's a reason. Take a look here. If you have the same exponent, you can multiply bases. So really you could say this is just negative 2 times, and because you have the same exponent, you can multiply bases. So you could just get 2 to the n, x to the n plus 3. This would be fine. And this is over n plus 1. I mean, that's fine. This is fine. This is fine. This is fine. There was just too many exponents for me. So I'm looking for this one just because this looks more friendly for the ratio test, which I have to do in a minute. So if you're trying to write the McLaurin series, just to review quickly, I know ln of 1 plus x by heart. I replaced the x with minus 2x, which I did here. Then what I did in the next step, I raised both minus 2 to the n plus 1 and x to the n plus 1. That was kind of critical because in order to bring the x squared in and add the exponents, I need the x all by itself here. That allowed me to then add the exponents using the distributive property. So this would have been fine and perfect for full credit for the first part of the question. I went to this part on purpose here by just using laws of exponents so that I could just make it a little bit nicer for the ratio test.
Professor?
Yeah.
When you multiplied the x squared in, it didn't change the n under the sigma to 1? Because I know sometimes if you have like a constant outside, it would make it n equals 1.
No, you don't change. No, this does not change anything. Nope.
But sometimes it does, right? Like if you multiply something different, like there's like a 5 you take out.
No, nope, that doesn't change this. Nope.
Bjorn,
Yeah.
will you be posting these the slides that you're working on somewhere or no?
No, you've got a copy. You've got a copy. Yeah. Yeah, so make sure you take copy.
Bjorn, can you do that last step again right here? Just explain that again.
Yeah, so what I did here in this step was I decided to make negative 2 raised to the n plus 1. What I did was I made negative 2 to the n plus 1, negative 2 to the n.
Oh, no, I meant like on the next slide.
Yeah, no problem. So what I did here was, once you got to this step, if you have the same exponent in multiplication, you can just multiply the bases together. So that's why it just became 2 to the n, and then I just put the -2 in the front here.
I see. Thank you.
All right, so let me get ready. I'm going to get ready for the ratio test now. So the ratio test, I have the series in front of me. So that I have as -2. Okay, let's see. And then I have 2 to the n. And then I have x to the, I'm just copying it over, x to the n plus 3 over n plus 1. Okay, so I'm going to do the ratio test. Something you're allowed to do here, this -2 is a constant. It's kind of annoying and not necessary in the ratio test. So one of the things you could note is that a constant can just come in front. This will allow less work in the ratio test here. So really you just have -2 times this series. So it's better to just do the ratio test off of this guy. There's no reason to use the -2. It's a coefficient and can come outside. So now we'll get ready to use the absolute ratio test. -2 is on the outside. Absolute ratio, definitely absolute value because x could potentially be negative. So here we go with the absolute ratio test. Limit as n goes to infinity, absolute value, 2 to the n plus 1, x to the n plus 4 over n plus 2. Again, all I did was replace n with n plus 1. All three of those n's became n plus 1. And then we multiply by the reciprocal of the original.
Bieber,
Yeah.
where did the -1 to the power n go?
The -1 to the power of n, that went away before when it combined with the -2 to the n to become +2 to the n. That was the laws of exponents from earlier.
Oh, yeah, I get it. Thank you.
Yeah. Okay, so we have this part here. I'm going to stay on this same slide here and just take this. Inside here now, I'm going to work with the limit, do the algebra, and come up hopefully with the radius of convergence. Okay, so let's see here. So we have limit as n goes to infinity. Along this diagonal, we just get a 2, subtract the exponents, and then we subtract the exponents here, we get 2x, and then we can't simplify the binomial as n plus 1 over n plus 2. All right. So let's see how we're doing here. At this point, as n gets large, this thing here goes to 1. Coefficients of highest power, or L'Hopital's rule, derivative of the top over the derivative of the bottom. The whole thing then comes out to be the absolute value of 2x, which, by the way, the 2 can come out, and it's just 2 absolute value of x. So this is really critical here. As n gets large, that goes to 1. N behavior, horizontal asymptote, L'Hopital's rule, that becomes 1. This is what we get. We know we have convergence when this is less than 1, and that's less than 1. You're pretty much done, because if you divide by 2 here, this is the number here that winds up being the radius of convergence. Capital R is equal to 1/2. If you don't believe me, what happens right now, just to remind you, if you have absolute value of x is less than 1/2, well, that's absolute value of x is equal to 1/2. If we solve that, we get these numbers here. The center, of course, of Maclaurin is 0. Less than means shade in between. The radius is the distance from the center, which happens to be positive 1/2. So that's your radius of convergence, which is 1/2. You can kind of see it from this part of the inequality right here.
Professor?
Yeah.
So just to be clear, you got that less than 1 from the n plus 1 over n plus 2, right?
I got this. Now, the less than 1 has nothing to do with that. The less than 1 is because of the you know you have convergence when you're less than 1. This one is the limit as n goes to infinity. Convergence occurs when the ratio, the absolute value of the ratio is less than 1. The two that one.
So just to be clear, it's absolute value a to the n plus 1 divided by a to the n always has to be
For
less than 1.
convergence, yeah. Yes.
But that's not true for sine, right? Because sine is like the radius is infinity and stuff like that.
Well, no, if you're less than 1, you always have convergence. When you're less, you have to be less than 1 to have convergence, and you only have less than 1 on the interval of convergence here for this problem. With sine, which we're going to do in a little bit, the ratio is less than 1 for all reals. So you need the ratio to be less than 1, but it's less than 1 for these values in this case, and these values in the case of sine or cosine. Elizabeth?
Yeah, I was wondering how the ratio test would look like if we decided to keep the sigma notation with -1 to the n times -2 to the n plus 1 x to the n plus 3. Because I saw and I understand how you simplified it because it was a lot of like exponents, but the way you simplified it, I didn't like make as much sense as the one with all the exponents.
Yeah, all right. So what you're saying is if you stopped right here, right? Which one? This one?
Yeah, that one. And I decided to do the ratio test.
All
using
right,
that.
all right. That's fair. Let me do the ratio test off of that quickly because I could see people. You should get the same answer, but I know it's going to look different. So let me do that. Tadrima and Sophia, before I do the ratio test for Lisbeth, go ahead.
So for the -2 that you got after simplifying the last part further, like the one you circled in the purple,
Yeah.
it does the -2 constant just disappear?
Yeah, because it comes outside. So so it's part of the series, but it's not necessary in the ratio test because it would just be an annoying pesky constant that would cancel out anyway.
So you don't have to multiply it with the
No, because
ratio.
when you do the ratio test, it doesn't have anything to do with the ratio because it's on the outside. Because if it was inside, it would just cancel out and would be a waste. So you don't need it in the ratio test at all.
Okay, thank you.
Sure. Sophia?
So you mentioned that you can for the n plus 1 over n plus 2, you use L'Hopital's rule, but I just subtracted that. Would that be correct?
What do you mean by
Because,
subtract?
like so the n plus 2 is in the denominator and the n plus 1 is in the numerator. So I just thought to subtract them, and then I got 2x over -1. But if you did the ratio test, you would still get the correct radius.
I don't.
Correct radius of
You're talking about
convergence.
this part right here.
Yeah.
That you can't subtract anything. That's just 1 over 1. Nothing to do with subtraction. Can't
Oh
subtract.
no, that was before, like when we were simplifying it, you can't subtract it because like when I subtracted, you would get -1, but then if you take the absolute value, you would still get the same radius of convergence. So I don't know if that would work.
I don't. I'm still not following you. So where are you subtracting? So I'm going to go to the ratio test that I did. Where are you subtracting? I don't see where you're subtracting.
So you see in the bottom where you multiplied by the reciprocal. So I just subtracted the n plus 1 minus n plus 2.
Here? Oh, here.
Yeah.
You can't do that. You can't subtract.
Okay.
Yeah, you can't. This is a binomial and a binomial. There's no way to algebraically reduce them. You can only subtract them when they're exponents. These are not exponents. They're actually, they're just polynomials, so they do not subtract.
Okay, thank you.
Yeah, sure.
Professor,
Yeah.
I remember looking at my notes and it had like the limit as n approaches infinity with the absolute value for the ratio test, but then it said equal to 0. What does it mean again if it's equal to 0 then? Because right now we're assuming less than 1. I'm confused about the difference.
Well, no, sometimes this limit will wind up being 0 in which case the whole thing turns out being 0. 0 is always less than 1, which says that the series always converges. So that's what would happen there. So
That makes sense.
yeah,
Okay.
yeah. Go ahead. There's a bunch of people, and I have to go back and do Elizabeth's way. Go ahead.
So for our equation, for my equation in Maclaurin series, it's -1 to the n times -2x to n plus 1 times x squared over n plus 1, and it's equivalent to yours, but we credit for that.
Yeah, if it's equivalent, there's going to, because of the algebra with the exponents, if it's equivalent, anything equivalent would give credit. If you're sure it's equivalent, it would give credit. Yes.
Okay.
I'm going to do Lisbeth's ratio test because a lot of people probably would have left it in that form, and I'm going to do that quickly in a minute. But keep going. Sophia, Daniel, Neural, Adam, Amon. Go ahead. Keep going. Anybody?
So say if the question was asking like for the interval of convergence, how would you
No, I
test?
can't do that. I can't ask interval because there's too many problems with the endpoints. That was why radius was introduced. I'll limit my scope to radius on the midterm.
Professor,
Yeah.
just one more thing for this question. Let's say 2x was, let's say it was 1 over 2x. That means that as limit approach infinity, it would be approaching to 0. So would I write 0 as less than 1?
That well, then 0 is in that case, what you're making up. Yes, but that's not going to happen. But 0 would be the case there, and then it would be radius would be all reals. That what you just said is not really happening. But let me do number 2, and hopefully you'll see what I mean. All right, Neural.
Oh, I just stopped.
Okay. All right, Elizabeth, let me do it quickly here because this is where people may have done the ratio test, which makes sense because they didn't simplify. And then I'll go on to number 2. Okay, so let's see here. Okay, so limit as n goes to infinity. Absolute value. So we have -1 to the n plus 1. And then this is -2 to the n plus 2. Let's see if we can do this here. X to the n plus 4. N plus 2, and then times the original, n plus 1. You see why I simplified it. It's just going to be a lot of exponent stuff. But you can do it this way, just a little bit more work. All right, so let me see here. All right, so let's see what happens. Let's see if I can quickly get the same answer. And then we'll go on to number 2. When as n goes to infinity, absolute value here. So I think I made a mistake here. So this should have been, oh boy. One of these is wrong. What should this was, what was it?
In the reciprocal, -1 is supposed to be just to the n, not the n.
All right, thanks. I'm going fast here. Let me just try. Okay, good catch. All right, so then this cancels here. So we wind up getting -1 to the first power. And oh, this should have been what too? What should this have been?
It's supposed to be n plus 1.
Yeah. Okay. And then I think I did the x right at least. Okay, so this is me going back. This is -1. The ends cancel. And then 2 minus 1 is 1. So you get -2. The ends cancel. 2 minus 1. Okay, so -2 to the first. And then this becomes x. Subtract exponents. 4 minus 1 is 4 minus 3 is 1. So we get this guy. And then you get n plus 1 over n plus 2. It's very, very similar. So let's just see what happens here. -2 times -1 is just the 2x. See, it's the same thing now. Because as n gets large, this goes to 1, and then you're just left with the absolute value of 2x, same thing. So that's what happened there. It's the same exact thing.
I had a question.
For x, I would have said it was x to the n power because it would have been 4 minus 3. But so wouldn't it have been n plus 1?
No, because when you subtract the exponents, n minus n is 0, and then 4 minus 3 is 1.
Oh, so you're subtracting them based on expression wise. Okay, yeah.
Exactly. Krista?
I might be missing something very simple here, but how do you change the
the n+1 to the n+2. That's what I'm getting a bit.
Because when you do the n+1 term, if that was already an n+1, wherever there's an n, you put an n+1, which becomes n+2.
I see. Okay.
Okay. All right, let me go
Is
on.
there any time when we would not use an absolute value for the ratio test?
Well, if you have if it's not a power series and there's only positive terms, you can get rid of the absolute value. It doesn't hurt to always have the absolute value, and if you want to be sure, but the only time you can get away with it is if you're sure the terms are always positive.
Okay, thanks.
Sure. Shreya?
Bernard, Professor, just like a quick statement. Power series can have n in the exponents, but if the n's are not exponents and they're just like a variable, I guess, then it wouldn't be, right?
Well, no, something like this is a power series. So like this is a power series. There can be n's all over the place, but as soon as there is x raised to a power of n, that's a power series. So this whole thing is a power series. If you have just this by itself, then it's not really called a power series. But you can have all sorts of things with n as long as there's an x to the n in there, which makes it a power series, which are all of our Maclaurin series are power series.
Thank
Zoe?
If we forgot that ln 1 plus x, is there a way to find it using derivatives?
Yeah, that's really a pain here because there would be a chain rule, a product rule. Yikes. If you didn't know ln of 1 plus x, this would take too long for the midterm, way too long. You have to know the Maclaurin for ln of 1 plus x, sine and cosine, definitely by heart.
Do we have to know the Maclaurin series for e to the power of x?
Yeah, you should know e to the x also. That's the easy one. Knowing e to the x is a good idea also.
Okay, thank you.
Yeah, e to the x is the easy one, but knowing, I usually have people know those four: sine, cosine, ln of 1 plus x, and e to the x. Arctangent is optional. It came up on the last review. All right, let me go to the next one.
Last question.
Yeah.
How can we determine when n is equals to 0 and n is equals to 1? Because in some questions I solved from the textbook.
Because it'll depend on what I want to do. If sometimes 0 will make the expression undefined, so I'll start it at 1 or I'll start it at 2.
Okay. And is it like for Maclaurin series, like in general definition, there was a formula, summation of n to 0 till infinity, f raised to n of 0.
That's the expression that's the Maclaurin polynomial formula that builds the polynomial.
Okay.
Yeah,
it applies for every other, right?
That's this the thing you're talking about is this thing.
Yeah, for that there was the formula that was given of the summation.
Yeah. That you're just giving to me that in sigma notation. That's all.
Yeah, so it applies for every other equation, right?
I don't understand what you mean.
I mean, that general formula, I can use it for all the equations, right? If I want to
everything comes from that, right? But that would be crazy on the midterm to build x squared ln of 1 minus 2x from scratch. That would be too long for a midterm. I mean, you can do it if you had, 4 hours, but that's going to take a long time to build, in my opinion. Yes, but everything comes from that. Yes.
Okay.
Professor?
Yeah.
Or will we get like a problem where like the ratio test wouldn't work and we'd have to prove it and say it doesn't work because you get the bracket? I have no idea how you get the bracket.
No, we're not doing that. No.
Okay.
With
Professor,
ln,
can you quickly? You can go ahead.
With ln of 1 plus x, are we supposed to know the Maclaurin series at n equals 0 or n equals 1? Because at the table I'd used, I realized it was at n equals 1, but maybe I'm supposed to know it at n equals 0.
I don't know. I thought the Maclaurin I gave you started at 0, wasn't? I mean,
Okay, maybe I got a table from the textbook that started
yeah,
at
because
1.
the table from the textbooks does it at 1 and then just changes the exponents. So you can use either one. Either one is fine. But the one I decided to start the power series at 0. That's what I decided to do. But yes, the one in the textbooks usually start at 1. But you'll notice it looks different inside the sigma, but it is equivalent.
Okay, thank you.
If you start the series at 1 or 0, does it really make it? Does it just make a difference depending on what
it's
series you're using?
It's not going to make a difference in the ratio test itself. No, but it'll change the sum or it'll change the expressions. But I often start at n equals a certain number to not make the expression undefined. It can be arbitrary if you want it to be, but I usually start at the specific n because I don't want it to be undefined.
Okay, thank you.
Hey, Professor, can you quickly write down the formula for the ratio test just so I can have it in my notes?
Okay. Let me do that. And then we got to move. So it's probably, you probably do the absolute value of a sub n plus 1 divided by a sub n. That's really the ratio test in symbolic form.
And just to be clear, the ratio equals a half and not negative a half because we're taking the absolute value.
Yeah, there's no, right, exactly. There's the radius, you mean the radius though.
Yeah.
The radius is always a positive number.
So when we substitute it into the, I'm spacing on the name, but the inequality where it'll be -1 is less than x, which is less than 1. We always lean towards the positive side.
Well, no, it's always in both directions, but it's a positive distance. The radius is a distance. So the distance is a half in both directions.
So if I were to just write it that way and not include the negative aspect of it,
That's exactly right. Yep.
Okay.
Yeah. All right, let me do the second one here. Find all antiderivatives, find the antiderivative of f of x equals sine x to the fourth. Okay, so in order to do this, you've got to know the Maclaurin series for sine x. So there's one you know by heart. We started our lectures with this guy. And then here we wanted sine of x to the fourth power. So if we try to build that guy, we then just replace the x with x to the fourth power. That winds up becoming x to the 8n plus 4 by the laws of exponents. So again, all we did here was replace x with x to the fourth, and then we multiplied the exponent by the power using the distributive property, and this is what we get. So that is, in fact, the Maclaurin series for this guy. You're looking for the antiderivative of sine x to the fourth dx using Maclaurin. So when you wind up doing that, of course, it's c plus. And this is where you're going to have to do the power rule of antiderivatives inside the sigma. So this becomes -1 to the n. Adding 1 makes this 8n plus 5. Divide by 8n plus 5. And then we have 2n plus 1 factorial. So that would be the antiderivative of sine x to the fourth power. Just take a moment to copy this because I'm going to use the same slide to do the ratio test off of the answer just so it's clearer for you to see. But that would wind up being the antiderivative of sine x to the fourth.
Are we supposed to memorize the antiderivative?
No. You sine x is this, sine x to the fourth, you replace the x with x to the fourth. The antiderivative just means whatever you get here, you add 1 and divide by the new power. That's the antiderivative rule.
So why wouldn't we add 1 to the n?
Only to the power, because 8n plus 4 plus 1, when you add 1, you literally add the number 1. Combine like terms, Lisbeth, and that's 8n plus 5. That's why. You don't add, you can't.
Yeah, I understand that part. I'm just confused on why we're not adding 1 to the n in front of the -1. Before the n?
Because there's no x. You can only do it to a power of x.
Oh, okay. All right. It makes more sense. Thank you.
You got it. Sure. Okay. So now I'm going to do the ratio test on this guy. So let's try that. You don't need to do it on the plus c. So here comes the ratio test. So limit as n goes to infinity, absolute value. You have the -1 to the n plus 1 if you really want to do that. Because that's what I just do here. Come on. X to the this is going to become, remember now, n plus 1 term means wherever there's an n, you put in n plus 1. So that's going to wind up being 8n plus 1 plus 5. So that's going to be 8n plus 13. Over 8n plus 13. And then 2n plus 1 factorial. Wherever there's an n, you put an n plus 1. That's 2n plus 2 plus 1, which is 2n plus 3 factorial. Okay, so let's keep this going. Then we have the reciprocal of the original. So that's going to be 8n plus 5, 2n plus 1 factorial, negative 1 to the n, and 8 and x to the 8n plus 5. Iman, go ahead. Iman? Iman, you have a question?
Hi, yeah. How did the 8n plus 5 become 8n plus 13?
Because remember, there's an n here. You put an n plus 1, so it's here. So when you do the distributive property, it's 8n plus 8 plus 5. So then it's 8n plus 13.
Oh, okay, thank you.
Yeah. Christian?
Just to check, we are using the antiderivative of sine x to the fourth to use as the ratio test.
That's what I'm asking you to do the ratio test on, the antiderivative, correct?
May I ask why?
I think because I said to. In the question, I think it said, and find the radius. So find the antiderivative using the power series and find the radius of convergence using the ratio test. So
Okay.
I implied to do it on the antiderivative. Okay, so now let me simplify this here. All right, so let's do some algebra. All right, limit as n goes to infinity. We've got the absolute value, so we got negative 1 to the first, x to the, well, 13 minus 5 is x to the 8th. Here we wind up getting, well, there's still an 8n plus 5 up here. There's still an 8n plus 13 down here. But these factorials is what's going to change everything. This is going to wind up being 2n plus 3 times 2n plus 2 times 2n plus 1, which hits that guy and goes away. So you might be like, oh, this is a disaster, but in fact, it's really good. See, in this particular case here, all the n's, there's an n to the first up in the numerator, but there's an n cubed in the denominator. So that means the degree of the denominator is bigger than the degree of the numerator. The whole thing for all x has to go to 0. The limit for every single x value would have to be 0 based upon all the n's here. Nothing's canceling. It doesn't really matter. The point is that there's an n cubed and an n to the first here. So this has an n in the denominator that can't go away. The whole thing is going to go to 0. So this winds up being a little r, which means the radius of convergence is all reals. It means convergence all the time, which we kind of expected for something to do with sine. Convergence always. So that's the radius of convergence being infinity.
But how does that apply to the negative one and the one you were speaking about earlier?
I keep saying what the question is.
Remember, like negative 1 is less than r is less than 1, or like the absolute value of something of r?
Because the number 0 is always between negative 1 and 1. That means the series always converges, radius of convergence infinity. That's what it means.
Oh, the radius is infinity, but r is still less than. I was confused with big R and little r. I'm sorry.
Right. Now I think you have it. Now I think you got it.
Professor Bernard,
Hmm?
will you explain again how you got 0? Because might be like I couldn't hear you. Sorry.
Because there's an n cubed in the bottom and an n to the first in the top. So even if you canceled somehow, there would still be an n squared in the bottom. So as n gets large, if n is in the bottom, that means the whole entire fraction is going to go to 0.
I see. Thank you so much.
Are you always looking at the ends? Like you're always looking at the n exponent, you're never looking at the x for the limits?
Pretty much, yeah, you only look at the ends because look what like n that's moving, not x.
Oh, okay, that's right. Yeah, thank you.
Yeah, good.
And R
Can you
is
repeat that?
capital R is to infinity because the interval is negative infinity to infinity technically.
Right. The interval gives you the radius. This is the ratio. Little r is ratio. This is the radius. Correct. All right, let me go.
Anytime you get a ratio of 0, it'll go to infinity.
Right, because little r, if little r is between -1 and 1, then the series converges. For all x, little r is 0, which means the series converges for all x, and we denote that by saying capital R is infinity. I got to go to the next one. All right, 3.
I had a quick question.
All right, go ahead.
So when we were canceling out, you mentioned how the top numerator, the n has the first power, and then the denominator, the n to the third power, but I didn't see a third power with the n.
Yeah, you do. N.
It was divided by 3, wasn't it? Oh, you're counting all n's together being multiplied?
Yeah. Mm-hmm.
Okay.
Yeah, and there's no way to cancel anything, so they're there. They're definitely there.
So since we weren't able to cancel, our best bet is sort of to combine and see where the highest power is in this case.
Yeah, because what's going to happen is you can't, even if you did FOIL and all this stuff, which is a waste of time, you're going to get linear over a cubic. So if the degree of the numerator is lower than the degree of the denominator with a fraction, then the limit automatically goes to 0.
Okay, thank you.
Sure. All right, third one. Okay. Find a geometric series in sigma notation with a first term of 2 and a sum of 3. So this is a case, because it's geometric, sum equals a over 1 minus r. So this is actually not a hard question. It says the first term is 2 and the sum is 3. So you're really just plugging directly in here. First term is 2, sum is 3. So if you can get an r when you solve for r algebraically, if the r is between -1 and 1, we know that we have convergence and therefore we have the geometric series. So if we cross multiply here, I wind up getting 3 minus 3r is equal to 2. So then if I try to solve for r, just using basic algebra from 7th grade or something, you wind up getting this, and r winds up becoming positive 1/3. So you do get an r that is between -1 and 1. Therefore, a geometric series does exist. The formula that we've been using for a geometric series is n equals 0 to infinity, a r to the n. That's the formula we've been using for a geometric series. So if I try to do that here, I get n equals 0 to infinity. A, of course, is the first term, which is 2. 1/3 is the ratio raised to the n. So this is, in fact, the answer to question number 3. There is a geometric series, and that's the formula for it. Go ahead. Question, Elizabeth?
Oh, I forgot to lower my hand, but I was going to make a point that for this problem specifically, I said what you said, but I wasn't sure how to show it mathematically, so I just stated the rule. And I stated how what is truly important on whether it converges or diverges isn't really the a value itself, it's the r value.
That's right.
So if I put down the exam would have been fine if I didn't do mathematics for it.
But did you get this though at the end?
I didn't substitute for r. I just showed how it wouldn't matter what.
Right, but you have to, because it says find the geometric series or show it doesn't exist. So you'd have to do this. You'd have to get here.
For both value, for both term where a is 2 and it's 3.
Yeah, this is before you have to have this, because there is such a geometric formula, and we had because there is one, you had to find one. That was part of the question.
Oh, okay.
Yeah.
Professor?
Yeah.
And also, technically speaking, if we just took that series we just got right now and we put that into the ratio test, we'd also just get 1/3 as the answer.
Yes, right, which is overkill, but that's exactly right. Yes.
So if r was not in the range of -1 to 1, it would not be the series would not exist, or it would be like not
Right,
possible.
right. Then you'd say if you got like R is 3, you'd say therefore R is outside the interval -1 to 1, and the geometric series cannot exist. That's what you would say. Correct.
Okay, thank you.
Sure. Shreya? Maybe you're
I'm sorry, I forgot to lower that.
okay, no problem. All right, let me move on. Okay, so number 4. Okay, 4. So 4, converge or diverge, n equal 2 to infinity of 1 over n ln n. Okay, so this is a series you have to figure out if it converges or diverges. There's no factorials. There's no n in the exponent. It's probably an integral test question. So in order to do the integral test, I'll just go to the side and find the antiderivative first of 1 over x ln x dx. This question is best handled by u substitution, letting u equal ln of x. Du is 1 over x dx, so it's a perfect match. So it's 1 over integral of 1 over u du, which gives us ln of the absolute value of u plus c. Ironically, it's ln of the absolute value of ln of x plus c. So when you find the antiderivative, no limits yet. I just found the indefinite integral. I didn't do this the way the book did it. I threw the bounds out for a couple of minutes just to find the antiderivative, which is this guy. Now I'm going to go back and do my work with the improper integral. So now I'm going to go back and do the integral from 2 to infinity of 1 over x ln x dx. And then I'm going to do the limit as b goes to infinity, integral from 2 to b of 1 over x ln x dx. Go ahead, Adam.
I'm just very confused about how we go from integral of 1 over u du and then equals ln a absolute value of u plus c. Because when I tried doing it, I think I probably did it wrong, but I got I simplified it to integral of u to the -1 du, and then I tried to do the reverse power rule, and then I ended up getting.
That's the one. I mean, that's really good because you're trying to understand what happened. But in Calc 1, they were supposed to resolve that, because if you try to do that, that's the one case where the power rule fails, and it turns out that the natural log is the way to get the antiderivatives. That's the one case where the power rule fails, and that's a rule from Calc 1, antiderivative of 1 over x is ln of absolute value of x plus c.
Professor?
Yeah.
Why did you use absolute value?
Because that's a whole other story from Calc 1. Absolute value is there because of the, it's a domain issue when you go backwards. I can't get into that tonight, but there's an absolute value around the x. It's a domain thing. You have to have the absolute value. It's not really necessary here when we do the problem because the numbers are positive, but technically speaking, the absolute value is around that.
So I just assume that integral of 1 over x dx, integral of 1 over x dx is equal to ln of absolute value of x plus c.
I would memorize that at this point because it's a whole Calc 1 story. Yep.
Okay, thank you.
Sure. Okay, so going here now, we wound up having limit as b goes to infinity, and then the antiderivative. I can drop the absolute value because all the numbers are positive. So I'll do that here. And I have x equal 2 to x is equal to b. So then I have with the fundamental theorem of calculus, limit as b goes to infinity of ln of b. I have ln of b minus ln of 2. Now, as b gets large, natural log of b gets large. Ln of large is still large. So although it's getting there slowly, this whole thing is going to go to infinity. So you have infinity minus a constant. This is infinity, and we've proven divergence. So that's diverge.
When you mean justify, are we supposed to write an explanation?
No. I just mean show work. Justify for me is just show work. That's
okay.
all. Yeah.
Why would it be diverge if we made it? Oh, forget it. If it was converge, it would have been 0.
It would have been a number. It would have been a finite value. Yep. Okay.
You need to provide like an official explanation.
No. You don't have to be like, it's not like a court case, right? Yeah, ladies and gentlemen of the jury, just write diverges. That's perfectly fine. You got it. Okay. All right, number 5. All right, let's see here. Last one. Okay, so this is write a second degree Maclaurin polynomial for the function 3x plus 8.
It's the only fun problem.
The only fun problem. Okay, this one, hopefully everybody was happy. Okay. So this is f of 0 plus f prime of 0 x plus f double prime of 0 x squared over 2 factorial. Okay, so you had to find some derivatives here. So the derivative is 1/3 3x plus 8. 1/3 minus 3/3 is negative 2/3. Hold on, let me just find the derivatives. And then we get negative. So hold on a minute, we made a mistake here. So this was
times
3. Yep. Okay. So that was the chain rule for the derivative. And now let me find the second derivative. So I found the first derivative and we got this. Okay, so now the second derivative is going to wind up being, so let me just keep it in this form. It's easier. So negative 4/9 3x plus 8 minus 2/3 minus 3/3 is minus 4/3. Don't forget there was a 3 here and another 3 pops out from the chain rule. So I'm going to simplify this mess in a minute, but that's how we're starting it off.
Bjorn, you wrote -5 to the -5/3, but you said negative to the -4/3.
Oh, I meant negative 5/3 because
Okay, thank you.
negative 2/3 minus 3/3. Sorry about that. Negative 5/3. Okay.
Wait,
Yeah.
I'm sorry. I think I'm got something wrong. I got for the second one, it's -2/9. It's definitely -4/9, right?
No, I probably screwed it up. I think I screwed it up. It should
Yeah, I
be.
got -2/9 as
You're
well.
right. Yeah, it's my fault. It's my fault. So let me just fix this. I always go back and look. Good catch. Okay. All right, now I think we're okay. Yes. All right. So now let's just hold on. Let me put the function back here. All right, so let me just plug everything in now. F of 0 is 8 to the 1/3 power. That's the cube root of 8 is 2. So that's the first term. Now we're going to plug 0 in. So now you got a little bit of stuff to do from high school here. 8 to the negative 2/3 power. That's the cube root of 8, which is 2. 2 to the negative second is 1/4. These 3's cancel. So it looks like I just get 1/4 x. Does everybody agree? Did you get that?
Yes.
Yeah, it should be 1/4. So again, the 1/3 and the 3 cancels, 0 goes in. You have to know from high school how to do 8 raised to the negative 2/3 power without a calculator, and we get 1/4 here. Now you do the next one. So here, this is actually nice. This is 9. This is 9. So this cancels. So now you got a little bit of work to do. 8 cube root of 8 is 2. 2 to the negative 1/5. So that's going to wind up being 1/32. So just watch me for a minute. You've got -2. And I just said that that's going to be over 32. And you have x squared divided by 2 factorial, which is 2. Now remember, dividing by 2 is the same as multiplying by a half. So these 2's are going to cancel. So the polynomial that you get at the end should be 2 plus 1/4 x minus 1/32 x squared. This should be your p sub 2 of x and the final answer that you are looking for here.
Bieber, and if we decide not to simplify that thoroughly, will we get points taken off?
Yeah, because I said simplify the coefficients here. So if I say simplify the coefficients, the factorial's got to go away.
Okay.
If I don't say it, then it's fine. But you really shouldn't have fractions within fractions anyway. But sometimes you could have something like, x squared over 9 factorial is good. 9 factorial is a large number, but you shouldn't have fractions within fractions. On our test, get rid of the factorial on our test so there's no confusion. Just for the one where I asked for the Maclaurin polynomial. All right, go ahead. Keisha?
So someone in the chat said, like, they mentioned what they were mentioning, they were asking like what the big R would be for the geometric series.
Big R for the geometric series. It depends on which.
Me too, dude.
The
I
one
am doing work right now, but that's because I have a midterm coming up.
I can't.
Isn't big R for the geometric series always going to be just 1? But if R is equal to x or x squared?
No, I don't even know. I'm not even sure what you're talking about because the geometric series in this question tonight had nothing to do with a power series. So there's no radius of convergence here. So
I just, cause like I responded and I just didn't want to like give out the wrong answer, and I said that like there's only going to be a big R if there's like an X on if R has a little has an X, because then like it's not an actual number, so it's like the radius of convergence kind of says what values of X does it converge to.
yeah, so right. So it doesn't apply to this, but in certain geometric series that are power series, like the one from the last review, not tonight's review, there was a radius of convergence because it came from a geometric series that was a Maclaurin series that was a power series. So there was a radius of convergence there. That did not happen for us tonight, though. It did not.
Okay.
Yeah. Thanks for being responsible.
We lose points if we left like exponents in our final form, or would that be not considered simplified?
I don't know, like for which one? The one
Like on number 5, like instead of 1/4, I had 1 over cube root of 8 squared.
No, you got to figure that out. Yeah,
Okay.
you gotta figure that out. Yeah. Simplifying means go further.
Bebern, can you go back to the previous page?
Yeah, I gotta go soon though, guys, because I can only do an hour tonight. But let me see. Where you were here? Yeah. Okay.
Bieber, roughly, let's say we simplify, right?
Yeah.
And while we're simplifying, we make an error when it comes to finding the square root of the cube root of 8.
So you lose
roughly how
points.
much we lose points?
I don't know. Maybe you lose a couple of points out of the 10 points for the question. So, I mean, you got to try to be careful. I mean, you got to know some basic arithmetic. I'm not going to ask you to do anything ridiculous, but you do have to know how to do something like that without a calculator. Just be careful. If you we all make human errors, but so there will be some small deductions for that.
Okay.
Yeah.
Bieber, could you re-explain why when the ratio equals 0, why it converges everywhere?
Right, because if the ratio is 0, the number 0 is always between -1 and 1, which means you always converge, which means you converge for all real numbers, which gives us a radius of convergence of infinity.
Okay, thank you.
Given that the midterm is going to be 2 hours, can we expect the questions to be like more time consuming? Or
no, not longer than this. Definitely not longer than this. So if you think if you think to yourself, oh, I could do this in 2 hours, uploading and downloading, that was my point. So in my mind, for the average student, and I say average student, in my mind, for the average student, this is a 50-minute test, and you have 2 hours, including the upload and the download. So there's like a built-in, in my mind, for the average student, there's like a built-in extra, like 40 minutes.
Say if we're like doing the tests, we have the tests on our laptop, but we're doing the work on a sheet of paper. We're just taking how are we uploading like the work?
You got to take a picture. You're gonna have to use
with our phone, and then we just upload it. Okay.
Yeah, that's okay.
If I were to scan it with like the PDF scanner as an app
Yeah,
and then
you
upload that
could,
PDF, that's
yeah,
fine.
you could scan it too. Sure, no problem.
So I have a roommate, and I'm not sure for the exam I'll be able to go to like a study room. If she's in the background, would that be?
That's
You guys
okay.
weren't specific about it.
Yeah,
Anymore. I wasn't sure if
because
that
you guys, this is you're in dorm rooms, so yeah, you have to be able to have the roommate there. What are you gonna do? Throw the roommate
No, I
out?
mean, like, I wasn't sure because there are some classes where I had to be by myself in a room to take these midterms. So I wasn't sure if you were gonna like.
No, I can't. I mean, that's so mean. I mean, you're going to throw the roommate out. I feel terrible. No, as long as the roommate's not participating, this is your home, so they can stay. Yeah, I'm not going to have them throw it. My gosh, that's like so ridiculous. So
Okay, thank you.
Yeah, that's fine. That's fine.
Do we have to use a pen or pencil, or is
You can use a crayon as far as I'm concerned. It doesn't magic marker. It doesn't matter to me what you use. So I don't. It's really totally up to you. No problem.
For number 4, is it okay if we write does not exist instead of infinity for the limit?
Limit should be does not exist. We say infinity, but limit does not exist means diverge. So that should generally be okay. Infinity is just a descriptive way of saying what's going on.
Bjorn?
Yeah.
So for number 1, when we find out the Maclaurin series for like ln of whatever, so whatever's on the outside, we could always multiply that in with the x.
Yes.
So it could be like x with a coefficient or anything, and we could always multiply it in.
Yep, that's right.
Okay. Well, what if it was like cosine of x?
You gotta know cosine of x is Maclaurin series. All right, I gotta go, guys, soon. So you gotta.
I just wanted to ask, what would be the best way to study for the midterm?
I would say use the 2 review tests I gave you. Take all the lecture notes that I gave you from the beginning of the semester, all the questions I did in class, write them on a separate sheet of paper and do them, and then use the notes as the answer key. Then as a 4th thing, I would use the WebAssign. So those are the things that I would do.
Okay, for my laptop, it doesn't allow me to like show my full like screen. Do I have to move my laptop back to show my hands? Or
No, let's not get crazy with this. Like, I mean, it's just the whole point is don't cheat on the test. Let's just. I don't want to get crazy with this. Just don't cheat on the test. I can't. There's people who are going to get nervous over like, oh my God, the screen isn't going to show my pinky when I'm. Don't get crazy with that. It's fine. Just don't cheat. The mic should be off and the camera should be on because we don't want to have people too noisy. So make sure the mics are off. And if there's a concern, go to the chat and the TA will converse with you.
Wait, but are you gonna clarify to the TA that like some people like only have like laptops and can solder hand at the same time without Well,
we're gonna be able to see you, right?
Mm-hmm.
Yeah, as long as we see you, the camera has to be on the whole time. Yes, like they have to see you. They have to see you, right? As long as I know we can't see. I know it's hard. Like here, I know it's hard to see. Like here, that's like the best you can do for me. I can barely see my nose to my hand. Just do your best without. Yeah.
Sorry. So as long as they can see our face and like partially plus of our arm, that should be enough because I can't tilt my computer that much.
No. Don't get crazy with that. We're not. Don't get crazy with the angle of the computer. The whole point is just do the test. Do the test responsibly, honestly, ethically. That's all. This is just to make sure we're not going to have surveillance camera to drones flying around your dorm room to see what goes on. Let's just try to keep it honest here. Okay.
There's
a lot going on now. I feel like we got crazy here. So I got to go now. So if you have questions, you're going to have to write. The TAs have office hours this week. Some of them on Monday and Tuesday. You're going to have to talk to them about it before the test. Obviously, some of you have the test on Thursday, so you have more time.
Professor?
Okay, yeah, I got to go now.
But can you clarify to the TAs that whatever you just said?
Good luck on the test. Yes, the TAs will know. Don't worry.
When are we getting the Zoom link?
The Zoom link is already there. The Zoom link is there. The only thing that's not there is the test yet. But the Zoom link is there. Good luck on your exam, everybody. The Zoom link is already online. Thank you and good luck this week. Hope everybody does well. Good spring break. Have a good fall break too. Don't forget
You
the
too.
Thursday class is not meeting on the 14th, but I'll email that to you. So I'll see everybody in about 2 weeks. No lightsabers tonight. I'll have I'm bringing you the force for the test. You're going to be fine. Okay. Good luck, everybody. Bye.